What's up everyone, in this video I'll be showing you how to solve the Square-1. So in this tutorial I'll be showing you the easiest method for solving this puzzle, as well as providing a really good foundation for speed solving this puzzle. Also, to make this tutorial easier, I will not be using any fancy notation or any long algorithms. I never found all that necessary to solve this puzzle, but if you want to get faster in the future, you can always learn that later. Alright, so compared to the 2x3, there's actually a few changes, actually 3 major ones. First off, the 2x3, you can see the edges and the corners are the exact same size, the exact same cube here, but in the Square-1 you'll notice that the edges are actually smaller than the corners, actually half the size. So if we have one edge here and put 2 of them here, that would equal 1 corner. Secondly, the 2x3 you can turn on every single side, but for Square-1 it's a bit different. You can turn on the top and bottom freely, which is nice, and also you can do some weird turns, like not just a full turn, you can do like a half turn, and that can still work. So same for the bottom layer, you can turn them both pretty freely. Now the change comes here, you can't turn the front and back layers, and you can only turn the right layer twice. So you can't turn it like this, you have to turn it like this. So if you turn it one time, it's going to lock up. So we want to turn it twice every single time. We can also turn the left layer, but for the sake of simplicity, we're just going to turn the right layer only twice. So again, right layer only goes twice. Now the last main thing you have to remember for this puzzle is that whenever you do a slice move, right before that, you want to make sure that there's a straight line here and a straight line here for you to be able to do the slice move. Now for example, if we have this layer misaligned like this, there's no line here. So therefore we can't do a slice move here. We have to make sure that there's going to be a line here, then we can do a slice move. Alright, those were the basics for the puzzle. Now let's get into scrambling. So turn the top and bottom randomly, slice, and keep repeating that here. And one thing you'll notice is that the solve state is a cube, but when we mix it up, it's not going to be a cube anymore. It has some really weird shapes on top and bottom, and you'll notice that as you scramble the puzzle. And this might look a bit complicated, but don't worry, we'll get through this. Now before we even start turning the puzzle, we have to orient the puzzle correctly. So the way you have to hold the puzzle is with the top and bottom layers being the ones with the weird shapes, and then the left and right have the blocks here, like that. Now the way you want to hold it is have a small square on the left and have a big rectangle on the back left. So yeah, really important, you don't want to hold it like this maybe, where you have the big rectangle on the left. So you want to have it with the square on the left. It's just the conventional way of solving the Square-1. Now the first step of solving the Square-1 is getting the puzzle into a cube, something like this. We have a square on top and a square on bottom. Since that is quite tough, we're first going to try to get 8 edges in a row. So something like this, all corners on the bottom, and then have 8 edges here on top in a row. So to get these 8 edges in a row, we're gonna build them up in pairs usually. So we're gonna try to get the first 2 edges, then build up on it to get 4, and then try to get 6, and then try to make the final 8 edges. So the general way we're gonna do this is we're gonna build the edges up on top. This is gonna make it pretty easy to look at the pieces. And then we're also gonna build it on the left side, so the top left. So the main reason we're doing this is because we're always slicing on the right side, and if we keep everything on the top left, it's going to be preserved, and then it's going to change from a slice move. Also, it's quite important to know how to build up this left block. So there's 2 main ways to do it. You can insert it through the front, I would call it, and what you would do here is put the block here on the top left, and have an edge here on the bottom in this position, slice up, and you'll notice that it connects it with these edges. So now we have 5. Now the second way to do this is you want to put the block on the bottom left, and we're going to misalign the bottom so that we get the edge in the back here in this position, and from here we can slice, and that connects the block with the edge, and this is inserting through the back. So again, edge in the back, slice up, that connects all of this together. So now you know 2 ways to insert an edge. You can insert it through the front or the back. Alright, so first step, we want to get 4 edges together. This is usually quite simple. So let's evaluate the puzzle. It's actually pretty nice. We have 3 edges on bottom. So we do something here maybe. And then we have 2 edges here. Okay, so let's see what I can do here. I'm going to try to bring these 3 edges up top first. So again, we're going to try to insert it through the front. So we're going to have all the edges in this position right here, right of the slice line, so right here. And to insert it, we just have to do a slice move. And we're going to connect it with this one edge. So slice, and now we get the 4. So that was extremely easy. Okay, here's another example. That case was quite easy. This one's going to be a bit harder. So this one we have 2 here on top and there's no other big blocks. So let's try to insert an edge here on top. So we're going to misalign the layer here and notice that we don't have a clear line here, unfortunately. We have a line here, but not here. So since there's no good way to insert an edge in the front to connect the two and preserve the two, we can insert it through the back. Let's see if this works. So now we have the 2 in the back, and now we can see perfect. There's going to be a perfect slice line here, which means we can turn it, which is nice. Now we're going to try to insert an edge here in the back. So to insert an edge in the back, remember we have to put an edge to the right of this slice in the back here. So here, we have an edge right here that will connect here. So straight line here, perfect. Slice, now we get 3. Now let's try to get 4. So this line here, we're going to try to insert something else through the back. But again, we have 3 here preserved on the left of the slice, but we don't have a straight line here, which is not nice. So let's try to insert it through the front now. Perfect, now we can insert through the front because we have a straight line here and everything's left of the slice on the top left. Now to insert an edge here, we have to put an edge here. Perfect, we have one already here. And straight line here, which is nice. Slice, now we got the 4. Here's one more example to get the 4. We have, again, no big blocks. We just have a 2 here. So let's try to connect off this. We're gonna hold everything left of the slice to preserve it, but got the line here, but not here. So we can't turn the puzzle here, unfortunately. So let's try the back. We'll hold it like this, slice like this, but again, there's a line here, there's no line here. So we can't turn it like this, unfortunately. And again, if we do something like this, we're not gonna preserve the second edge, which is not good. So it seems like we can't preserve these two, which is unfortunate. So let's try to build off some other edge. For example, this one. So from here, I have one edge here on the left of the slice, and there is a perfect line here, which means we can slice. So we're gonna try to build off this edge, so we have to insert something through the front. So we have an edge right here, right of the slice, right here. So we can insert through the front like this. So now we connected the 2, perfect. Now let's try to get 4, because I see this 2 here and this 2 here. So let's try to connect and make 4. So like this. Okay, we can't actually slice here because there's no straight line here. So we're gonna lock up there. So let's try inserting through the back. Let's see if this works. Okay, now we have a straight line here, which is nice. Okay, we can't insert here either because, as you can see, this line, there's no straight line in the back. So we can't turn here either, which means we can't get 4 directly here. So unfortunately, we can't get 4, so maybe let's just get 3. Something like this. And we'll connect the 2 in the back here with the 1 in the front. That's good enough. There we go, now we got 3. So to make 4, we have to insert one edge through the back. So we have to have an edge here, which we do. And we also have to have the line for the slice, which we also do. So one more slice here. That can create the 4, which is perfect. So hopefully you guys didn't have too much trouble with getting 4. Basic idea is keep everything you want to build on the left to preserve it, and then insert it through the slice using front inserts or back inserts. Now we're going to try to get 6. This one's going to be a bit more complicated. So the first step for making 6 is to have a pair on bottom. And here we don't have one. You might have one, but I don't have one here. So to make a pair on bottom, we have to do something very similar to before. So first off, we have to have the 4 on the left of the slice. Again, we don't want to break up the 4 we already made. So instead of inserting to the top, we're going to insert to the bottom now. And one way we can make the pair here is we can take the edge here. It's going to go down here when we slice, and we can connect it with this edge to make the pair. But here we can get 3, but either way it's still a pair. So again, 4 is preserved, nice. We got line here, perfect, slice down. Now we got the pair on bottom. One more quick example, we got the 4 here, and then we want to make a pair on bottom again. So this time we can insert it through the back. We have an edge back here, and an edge here, and we're preserving the 4. Have a clear line here and a clear line here, slice down to make the pair. Now what the Square-1 should have is 4 on top and a pair on bottom, and the next step is just to insert the pair on top somehow. So here, let's try to insert it through the back. Like this, there's no clear line, can't do it. So let's try to insert it through the front. Clear line here, clear line here. We got the 4 here on the left, and insert the 2 through the front, and now we got 6 in a row, which is nice. Here's another example. We got the 4 on the left, and we got the pair here on the bottom. So let's try to insert the pair through the front. Have on the right side of the slice, left side of the slice. Can't turn it because of the line not being there, unfortunately. So let's insert through the back. this. Can't turn it also because there's no clear line here, unfortunately. So for this specific case, what I would do is I would put the pair on the left, just leave it there for now, and we're gonna kick these other two edges out of the bottom layer for now. So hold the 4 on the left and then slice here to kick the two edges out. So now these edges are kicked out from the bottom layer, we can hopefully insert this pair of edges to the top. So let's try to insert through the back. We have the two edges here on the right of the slice, and we have this line. Now we can connect it with the 4 to make 6, like this. Now we got 6. Alright, now let's get to the final step, which is getting the 8. Put all 6 edges on the left of the slice like this, and now put all the edges on the right layer in a way it will make 8, and then slice up. And we have the 8. So same thing here, if we have 2 on bottom like this, like a pair, it's also extremely easy. Slice up. There we go, we have 8 now. Now there's one case that's quite difficult, which is this L case. We have a 6 on the left here, but if we slice up, now we get 7 and 1, which is not good. And if we insert through the back, it'll be the same exact thing. Get 7 and 1. So the solution to this problem is quite simple. We're going to kick out 2 edges for now from the 4. So preserve the 4 and then kick out these 2 edges. And we're going to insert this L into the 2 edges. So insert this edge to the front, like that. And there we go. Now we know if we create 6 by slicing this edge up, we'll just go back to where we started. So we have to try something a bit different. So let's try to insert something through the back here and get the edge here through the back, right of the slice, and we have this straight line, which is nice. Now if we try to insert through these 4, it's gonna lock up, there's no straight line here. So we can think about it like this, with these 4 and kind of kick out this edge. Now we insert this through the back, insert the pair, and now we got 6 again. And this time we have 6 and a better case in bottom, the straight line. Slice one more time, and now we have 8. So now we have 8 in a row. Now to get to the final step, we have to solve it into a cube with the square on top and the square on bottom. So this is just a simple set of moves. Hold the 8 here in front, like this. And from here, we're just gonna slice and split the 8 in half. So now we have 4 and 4. From here, we're gonna do the same exact thing. Hold everything in the middle, so we're gonna split everything in half. So split the 2 into 2 and 2. Split these 2 into 2 and 2. Both in front. Slice. Now this next step, again, we're going to split everything symmetrically, but in a different way. We're going to split the top symmetrically like this. We have the line and line here. On the bottom, we're going to split it with the pair and pair here. So both still split symmetrically, but a bit differently from both layers. So from here, slice again. So now we're one step away from being a cube. Again, we're going to split everything symmetrically. So we're going to put this pair kind of thing in the back being split by the slice for both layers. So I'm going to put the pair in the back. So now we got this case. Slice one more time. And now we should have a perfect cube. Some of you might have the perfect cube on top and bottom, but might notice that the middle is misaligned here. And for this, just do nothing, ignore it until the end of the solve. This doesn't really affect your solve, since we're only caring about the top and bottom. So don't really worry about this piece being like this, we'll fix it by the end. Now before we get into solving the rest of the cube, there's one really important rule you need to know, and that rule is to always misalign the top layer by 1 edge. Something like this. Now the reason why this rule exists is pretty simple. If you don't do that rule, and you do a slice move, it gets out of that cube shape, which is not good. So if you misalign it and slice, you're still in a cube shape, which is always nice, no matter how many moves you do. As long as you keep the top misaligned and the bottom aligned like this, you'll always stay in a cube, which is really nice. Alright, now for the next step of solving the Square-1, we want to get 4 yellow pieces here on top. So 4 yellow pieces on the corners on top. And this would also create 4 white pieces for the corners on bottom. So we're going to solve this step kind of like cube shape. So first we're going to put 2 yellows on the left. So this is pretty simple. All we have to do is create a pair on top. So for here, I'm going to build off of this corner. So to do that, I need to put a corner in this position. So move the bottom like this. Now we have the corner set up. So insert through the front here and do a slice. Bring it to the left. And boom, we have 2 corners solved. So just like cube shape, the second step after making these 2 corners on the left is to make a pair on bottom, which is 2 adjacent corners like that. And here we don't have a pair, so we have to see how to make this into a pair. So what we can do here is first bring this corner up, and now we can do something like this. We can insert the corner backwards like this to create a pair on the bottom like this. So now we have the pair of yellow corners. Now the final step is pretty simple. Just put the yellow corners on the right of the slice and then slice up to make the yellow corners on top and the white corners on bottom. So that's the first step solved. For the next step of solving this puzzle, we have to get the top all yellow and the bottom all white. So we're gonna orient all the edges. Then before we get to the actual step, I'll show you one mini algorithm. So here it is. So what you do here is obviously misalign the top. You do a slice here. Now, this is the one time you break the rule. You're actually gonna align the top and misalign the bottom. Something like this. And you're gonna slice one more time. And then, of course, go back. So this move is actually called the M2, and it's pretty easy to see why. In 3x3, you have an M2 that looks like this, and you can see it looks exactly the same as this. So 3x3, M2 goes like this. For Square-1, it goes like this. Misalign, align, misalign, move back. That's the M2. The thing you'll notice about this M2 mini algorithm is that whenever you do it, you're gonna orient these two edges and these two edges. So a line here from up to down on top, up to down on bottom. M2 solves the orientation of those pieces. So the first step of this edge orientation step is to orient as many edges as possible. So to do this, you want to put any lines you see like this up to down. So here's one on top, and on the bottom layer we already have it like this. So if you see any lines like this on the top or bottom layer, hold them up to down on the top or bottom layer. After this, just do an M2 from here, misalign, align, misalign, go back. And that should orient all those edges. Here's another case. So again, I see a line here, so do the algorithm from here. Align, misalign, move back. And then that orients these edges. And here we actually do it again. So we have another line here, another line here. Slice, line, misalign, go back. And it actually solves the edge orientation here. That was a bit lucky. So do that trick as many times as needed until you see one of three cases. First case is the skip, which is what I see here. So everything's already solved here, which is nice. Another case you might get is if you have one edge not oriented on top and bottom, one edge and one edge. The third case is you get two edges here not oriented on top and bottom, which are adjacent and not opposites. So we're gonna solve this case first. And to solve this case, all I have to do is put the L here on top like this. So one going back, one going left, like this. Now for the bottom, we're gonna move the L in a way that one goes back, but also one goes to the right. So it looks like this. One back, one left, one back, one right. So after we set up this case with the L's, the mini algorithm to solve this is actually pretty simple. So slice here, we're gonna do a U prime, and remember to misalign this layer. From here, we're gonna do the M2 move. Now, next, we're gonna do the U, and then slice back. So again, here it is, slice U prime, do the M2 move, undo the U prime with a U, and then slice. And that solves the L here, slice, U prime, M2, U, slice. Now what if you have this case? So we have one here and one here. So the way you solve this case is you have one pointing to the right, one pointing to the back. So set up like this, slice, U prime, M2, U, slice. Now we have the L case. So L case, but this one left, one back, one right, one back, that's already set up. So from here, slice, U prime, M2, U, slice. And there we go. That solves the edges here. So the next step is to solve parity. So parity is something annoying that the Square-1 might have. So there's actually a 1 in 2 chance that you get this step. So if you're lucky, maybe you can just skip past this step, but if not, it's also not that bad. So to check if we have this step, we're gonna look at the top and bottom PLOs and see if they look familiar. So for the top, let's see if it's familiar. And actually this is quite familiar if you don't recognize it yet. It's this apron. So we have the corner going here, here, here. So this is a PLO that we're familiar with debitory, so this would be equal to good. Now let's check the bottom. So the bottom is quite weird. This PLO doesn't really exist in debitory. It looks kind of like an M perm from here, but from here it kind of looks like a E perm. So this PLO does not exist in debitory, so that's bad. So you want to check the top and bottom are familiar debitory PLOs, and if not, they're bad. If so, they are good. And to check if you have parity in your cube, it's actually pretty simple. So on top, if it's good, bottom is good, then it's good, obviously. If it's bad, and it's bad, bad cancels out and becomes good, and you have no parity. However, if you have one being good and one being bad, or one being bad and one being good, you have parity. Now if you do have parity, we have to go back into out of cube shape to solve the parity and then solve back into cube shape. So first off, we have to reverse the steps we did to get into cube shape. So first off, slice to get into this position. Now if you remember, we would want to get the lines on top and then the pairs on the bottom, something like this. So hold it like this, so that if you slice one more time, it becomes 2 lines, 2 pairs. After this, we made 4 in front, so we're just gonna put this to the side here, and this to the side here, like this. So that if we slice, now we get the 4 and the 4. From here, we're gonna do the parity move. So we're gonna move the 4 here to the back, but still left of the slice. Here, we're gonna move the 4 in the front, but still left of the slice. From here, slice here. And when you do that slice, you're gonna notice that the 4s are preserved and we're just changing these corners. And that solves the parity. From here, just solve the cube shape like normal. 4, 4, slice, put the L's on the left and right, put the pairs on the left and right here, slice, and then put the pairs in the back, like that, slice. And now the parity should be solved. So for the next step, we should permute all the corners, which should look like this. So first, what we should do is see if we have any solved adjacent corners. So on top layer, not these two, not these two, not these two, but these two are solved and adjacent, which is good. And it's pretty simple to tell if they are solved and adjacent. If they have the same color, like that, then they're solved and adjacent, which is what we want. Now let's look at the bottom. None here, none here, none here, and none here. So there's none on the bottom and there's 1 on the top. Now it doesn't matter if you have 4 solved of pair corners, or maybe just 1, or maybe even none. What you want to do is, if you have any of them, put them on the left, like this. The bottom has none, but if you had any, put all of them on the left. And if all of them are solved, kind of like this case, it doesn't matter how much you move the bottom, of course, the left will always be solved. So just leave it like that. From here, we're going to do another mini algorithm. So debitory, you might know this algorithm, which is the sexy move, which goes like this. This is a pretty standard alg for debitory, which is R, U, R prime, U prime. For here, we're going to do the same exact thing before square 1. So slice, U, slice back, U prime. And that'll be the sexy move for square 1. So for the rest of the algorithm, just solve the corner orientation. So this should be pretty standard. So I already have the yellow on left, so I need to put the pair on bottom, which is simple. Take this and then connect it here to make the pair, and then bring the pair up to solve the corners. Now if you look around, there should only be 1 pair of solved corners on both layers, so what I'm going to do is put them both in front. So it should be something like this. We have the left, right, and back. They have no solved corners, but in front there's 2 and 2. This is what you want. From here, do that same exact algorithm. Sexy move, and then from here solve the corner orientation. Solve the pair and then bring it up. And from here, the corners should now all be solved for both layers. Now the last step of the puzzle is to solve the whole cube by solving all of these edges. Before we get there though, there's one more algorithm you need to know. So this algorithm switches these 2 edges and switches these 2 edges. So these 2 and these 2. So front left and bottom, front right on top. This algorithm is pretty simple. Slice here, D, M2, D prime, slice. So again, slice, D, M2, D prime, slice. This is pretty much the same thing as the edge orientation alg that I showed from before, but instead of doing the U moves, you have to do the D moves. Knowing that algorithm, we could use it several times across the cube to solve each and every edge of the cube, solving the whole cube. So first we're going to solve the bottom layer, then we're going to solve the top layer. So for now, we're not going to touch the top layer pretty much at all. Here's how we're going to solve the edges using the algorithm. First, we're going to solve one line, that is 2 corners and 1 edge between it. Next, we're going to solve adjacent to it another line. So we get one big line. Finally, we're going to solve the last 2 edges to solve the whole layer. We will do the same thing on the top layer. First, solve one line, expand it to 2 lines, then expand it to the whole layer, and that should solve the cube. So let's just try to get one line on the bottom layer for now. So how this would work was you would try every single possible adjacent swap, like this, like this, like this, and like this, and see which ones would give a line, which is what we want right now. So let's try here. If you do that swap, it actually won't give us a line, so that's not good. So let's move on here, swap here. Actually, that would give us a line because if this goes here and this goes here, the red will move here, giving us a line. So this swap is good. So we put it in the position right here on the left in the front, and then the top, don't worry about it. From here, just do the algorithm. And as predicted, that should solve the one line. Sometimes you'll notice that there's no swaps possible that can actually give you a line. So here, nothing, here, nothing, here, nothing, and here, nothing. So what you would do in this case is just do a random adjacent swap with the algorithm. And from here, you should be able to solve at least one line. Alright, now that we solved one line, we want to solve the line next to it. So it could be either here or here. So let's try to solve this back line here. So I would try to switch these two to solve this edge like this. And that would actually bring the orange here, which is not a line, which is not good. So I can't really solve this line here. So let's try the front line. So in the front line, if I switch these two, it'll put the orange here, and that should give us the line next to the line. So we should get a double line if we switch these two. So again, align to where it should belong. One on the left, one in the front, and then from here, do the algorithm. And there we go. That should be 2 lines solved. Sometimes you'll get a case like this, one line here, and the line's not adjacent to it, but opposite to it. And actually you'll notice that any swap, no matter what, will not be able to get you the 2 adjacent lines. From here, again, just do the algorithm randomly one time. So, like this. And now it should be possible to solve the 2 lines next to each other. Finally, to finish off the layers, you'll always have 2 edges left, and these are pretty easy to swap. Just hold them left front, and then do the algorithm. And you should get one solved layer. Now let's solve the top layer. This is going to be pretty similar to the bottom layer, but one thing you have to notice is once you do the algorithm, you are going to mess up the bottom layer momentarily, but once you do the algorithm one more time, it should fix the bottom layer again, so don't really worry about the bottom layer. So here on top we have no swaps that really give us a line, unfortunately, so do the algorithm randomly one time. And now we can find the swap actually right here. This swap would make the line here. So from here to the algorithm, now we have the line. Now let's solve the adjacent line. This swap creates this line, which is what we want. So put it here. Again, with the add swap, you want to put one in front, one on the right. Remember that? So here we have this swap, which should create this line, which is what we want. So algorithm again. Alright, now we have 2 sides. What's remaining is just the final 2. So from here, right front, do the algorithm again. And we should solve the whole cube. Or maybe not. There's actually 3 different cases that you might get at the last step of the cube, and I'll show you how to solve each of them. So first off, last 2 here, do the algorithm. And you'll notice that the top layer is solved, but the bottom layer is still off by 2. And it's just these 2, nothing else on the whole cube, it's just these 2. If you have these 2 swapped like this, that means your cube has parity. So if you have this case, go back to the parity part of this video, solve the parity, solve the corners, and then solve the edges, and you should not run into this again. One thing that might also happen is that the whole cube is solved except for this annoying slice thing I was talking about before. So to solve this right slice, it's actually extremely simple. So for 3 by 3, if your right slice is messed up like this, you would do R2, U2, R2, U2, R2, U2, and that should solve it. For Square-1, same deal. If you have this bar flipped, do R2, U2, R2, U2, R2, U2, and that should solve the bar as well as the cube. So here's the final case. You can get everything solved except for the left and right bars. And what this means is you solve the wrong color on top. So that means if you put yellow on top, white should actually be on top. To solve this, it's also pretty simple. Just do slice, U2, D2, this switches the layers, and then slice back, and that should solve your cube. If you did get this error, however, you want to make sure that for the rest of your solves that you ever do on this puzzle, that you always solve white on top, not yellow. So that's it for this video. Congrats on solving your first Square-1. So as you can see, this puzzle was actually not too difficult to solve. It was a bit tedious, but eventually it wasn't that bad at the end. If you want to learn more about the Square-1 and how to get faster at solving the Square-1, in the description there should be some links to some videos if you want to check them out. So yeah, thanks for watching and hope this tutorial was helpful.